1.6 is function operations and composition. So let's just go ahead and start with example 1. It says let f of x equal 3x minus 4 and g of x equal 2x squared minus 1. Find each of the following. Part A, all it says is we're going to do two things. We're going to plug in 0 and we're going to add the functions. So it might help if you think about it as f of 0 plus g of 0. Now, that is not distributive property. I did not distribute. I'm going to plug in 0, and I'm going to add the two functions. So some of this you could probably do in your head. But if I plug 0 into the f function, I'm going to get minus 4. If I plug 0 into the g function, it's going to be minus 1, negative 1. But what we have to do is we're going to plug in 0 and we're going to add those two numbers. Answer is negative 5. F plus g of 0. So then part B, we're going to plug in 4 and we're going to subtract. Plug in 4 and subtract. Do you have a question? Okay. Plug in 4 and subtract. So again, if you want, you can think of it as f of 4 minus g of 4. F of 4, plug it into that f function. We've got 3 times 4 minus 4. That's 12 minus 4 is 8. And g of 4, we've got 2 times 4 squared minus 1. That's going to be 2 times 16, or 32 minus 1. That's 31. So don't forget, the second part of the question says to subtract them. We're going to subtract those two values. 8 minus 31, 8 minus 31, negative 23. Part C, you're multiplying. There's, oops, I missed. Hard to hit that spot right there. But you're multiplying f times g. There we go. F times g. You're going to plug in negative 2 and you're going to multiply them. Technically, you could do it in the other order if you wanted. If you wanted to multiply the functions first and then plug in the negative 2, that would work as well. But regardless, you've got those two things to do. So if you want to think of it as f of negative 2 times g of negative 2, that might be the easiest way to think about it. So f of negative 2, I've got 3 times negative 2 minus 4. Negative 6 minus 4 is negative 10. And g of negative 2, 2 times negative 2 squared minus 1. That's 4 times 2 is 8, minus 1 is 7. Multiplying those two things, negative 10 times 7, negative 70. Last one, we're plugging in 3 and we're dividing. F of 3 over g of 3. So f of 3 is 3 times 3 minus 4. So that's 9 minus 4 is 5. And on the bottom, g of 3, well, I've got 2 times 3 squared minus 1. That's 9 times 2 is 18, minus 1 is 17. So I've got 5 over 17. And I'm fine with fractions. Sometimes fractions are easier than decimals. I don't want to have to reduce that. I mean, it is reduced, but I don't want to have to change that to decimals, and I don't need to. It's good. Domain. We've talked about domain, and we think about domain as the x numbers. That's a little bit limited view, but it's a pretty good start for domain. But it's going to get a little bit harder now because things aren't going to work, and you have to look for what I call problematic x values. All right. If you're not looking at the graph, if you're looking at an equation, you can kind of think about the domain as what x numbers could I use? right? It's not, the X numbers is not a very good definition. It's what could I plug in? What am I allowed to plug in? And it's a lot of times it's easier to think about what you can't plug in, what you're not allowed to plug in. And that's what I'm talking about with problematic. So problems exist or problems arise when you have a 0 on the bottom of a fraction. So you need to look for an X number that's going to make a 0 on the bottom of a fraction. We don't want that. Also, we've seen problems arise when you've got a square root of a negative number. All right, so there are other problems that could come up, but those are the two that we're going to see the most, and we need to look for that. Okay, so keep that in mind as we're talking about domain. Number two, we're multiplying these two functions, f times g, and we're plugging in x. Sometimes students get confused, but we don't have to do that extra step of plugging in a number. We're plugging in x, and we already know what it looks like when you plug in x. That's what the f function looks like with x plugged in, and that's what the g function looks like with x plugged in. So all we're doing is we're taking f of x times g of x, or 3x plus 1 times 2x minus 8. This looks like an algebra problem that we've done a million times. Some people call it a FOIL. I think it's better to call it double distributive property. I'm going to distribute the 3x. It's 6x squared minus 24x. I'm going to distribute this 1, and I get plus 2x minus 8. You shouldn't need to be copying this. You know how to do this already, right? I've got like terms here. Combine those. That's minus 22 or negative 22x. 6x squared minus 22x minus 8. That is the answer. But now we have to find the domain. Okay, so the domain, we have to look for these problems. All right, and if there are no problems, then the domain is going to be all real numbers. Skipped that part, didn't I? A lot of the times the domain is all real numbers unless there's a problem that comes up, okay? And so we look at this answer that we just had in problem number 2, and we say, is there any place where I could get 0 on the bottom of a fraction? No, that can't happen, so I don't have to worry about that. Is there any square root where I could get the square root of a negative number? No, so then I don't have to worry about that. What's the domain of this? Well, there aren't any problems. If there aren't any problems, then the domain is going to be all real numbers. Meaning, what am I allowed to plug into this expression? Anything I want. I can plug in anything I want. Okay? It's probably not going to happen on the next one. So the next one, we're dividing f of x by g of x. And f of x is just 3x plus 1. And g of x is 2x minus a. And if we could reduce that fraction, we would, but there's nothing really to do there. That's my answer. Okay? Now, for the domain, you need to think about, well, maybe it's all real numbers, but you have to think about those problems. So is there any place where you could get a 0 on the bottom of a fraction? Well, maybe. All right, we have an x on the bottom of a fraction, so that could be a problem. I don't see any place where I could get a square root of a negative number, so I don't really have to worry about that one, but I do have to worry about 0 on the bottom of a fraction. That could be a problem. All right, and so essentially what you want to look at is that bottom and just say that bottom's not allowed to equal 0. That bottom is not allowed to equal 0. So let's just say, well, 2x minus 8 is not allowed to equal 0 because that's going to mess up my fraction. So solve that equation. Add 8. So 2x is not allowed to equal 8. Divide by 2. X is not allowed to equal 4. Think about it. If x was equal to 4, you plug in 4, you're going to get 0 on the bottom of a fraction. That's going to be an error. Okay, on your calculator, it might say domain error. That's what they're talking about because 4 is not in the domain. Don't think about domain as the X numbers. Think about it as the numbers that I'm allowed to plug into this expression. I'm allowed to plug in anything I want into this expression. I don't know what the answer is, but I can plug in anything I want except this number right here, -4. All right, everything except -4. So your domain is everything except 4. I didn't mean to say -4. Everything except 4. So on a number line, if you look at everything except 4, there's a hole right there. Think of it like this. Negative infinity is over here and positive infinity is over here. Basically, we've got two pieces. And this piece right here says from negative infinity to 4, parenthesis, because it's not equal, unioned with this piece over here, which is from 4 to positive infinity. That says everything except 4. Question? Okay. So kind of the same thing. This says we're going to add the two functions. And I'm going to skip a step here, but f of x is going to be 2x plus g of x is going to be this square root of x minus 5. And there's really nothing we can do with that. That's all there is to it. All right. As for finding the domain, I don't have to worry about a 0 on the bottom. I don't have to worry about that. But I see a square root of a variable, and so it's possible that I would have some x value that gets me a square root of a negative. So I do have to worry about that for the domain. Okay. What's my potential problem? Well, my potential problem is this expression right here. Okay. So, oops. This x minus 5 can't be negative. That thing under the square root can't be negative. So another way of saying it is it has to be positive or 0. Another way of saying that is this expression has to be greater than or equal 0. That expression can't be negative. So I know that x minus 5 must be greater than or equal 0. I'm going to add 5 over x is greater than or equal 5. That has to be the case. If that's not the case, I'm going to get the square root of a negative number. That's not real. All right. So if you look at a number line would have a filled in circle and an arrow to the right. So remember that's infinity. So your domain is going to be bracket 5 to infinity. And what that's telling me is I'm not allowed to plug in 3. I'm not allowed to. If I tried to plug in 3, think about it. If you tried to plug in 3 into that expression, you're going to get the square root of -2. Not going to work. That's going to give you an error. Okay. 4.9. Am I allowed to plug in 4.9? 4.9 minus 5 is -0.1. I'm not going to be able to do the square root of -0.1. All right. It's going to have to be at least 5. So that's your domain. Your domain is not the x numbers. It's what I'm allowed to plug in, or the x numbers that I'm allowed to plug in. All right. So g over f. G over f. So we've got, there's g of x, and there's f of x. So now we've got a fraction, and so now we have to worry about 1 over 0. We have to worry about a 0 on the bottom of a fraction, and we have a square root of a variable. So, and we have to worry about that. We have to worry about both of those things. All right. So we would know that x minus 5 must be greater than or equal 0, like we just did. That said x is greater than or equal 5. But we would also have to say that this thing on the bottom does not equal 0. And this thing on the bottom, divide by 2, you're going to get x. Well, x does not equal 0. And so, I don't know. I don't really like this example because if you've got 0 and you've got 5. If we have to be greater than or equal 5, like that, then who cares that we can't equal 0? All right. As long as we're bigger than or equal 5, then we've already got the 0 excluded anyway. So a lot of times you'll have to put it together into two statements, but in this case, as long as we are greater than or equal 5, we're good. All right, so I know students really struggle with that domain. Make sure you ask questions here. This problem right here, number 4, is a lot easier than it looks, okay? But the hardest part is just being able to see the graph. This says f of 3 plus g of 3. And I wanted to use those colors because my graph has two different colors. Notice the f function is blue and the g function is red. So if you want to know what f of 3 is, you have to realize that that 3 is an x number. And f of 3 is shown on the graph. So what you would do, here's the origin. I go over 1, 2, 3. That's x equals 3 right there. And you go to the graph, and the graph hits that point right there, which is 1, 2, 3, 4, 5, 6. That's negative 6. That's the point 3 comma negative 6. So f of 3 equals negative 6. I get that straight from the graph. Straight from the graph. So g of 3, okay, here's the origin. 1, 2, there's 3. And the g function hits that point right there. That appears to be 1, 2, 3. That is the point 3 comma 3. When x is 3, the g function equals 3 right there. Students have historically struggled with this problem because they can't see it on the graph. They don't know where they're looking and their eyes go crossed. But all we're doing now is negative 6 plus 3 is negative 3. So this next problem says g of 0 minus f of 0. So look at the g function, okay? The g function is the red one, right? And find where x equals 0. X equals 0 right there. That's the point 0, 0. When x is 0, the g function is 0. I can see that straight on the graph. Now you look at the f function. F of 0 corresponds to this point right there. F of 0 equals 4. Very good. So all I'm doing is 0 minus 4 is negative 4. Okay. Number 5 is really the same kind of thing, except now we're looking at a table instead of a graph, but it's the same thing. People's eyes go crossed when they look at this. All right, we want f of 1 plus g of 1. So you got to remember, I think what people struggle with is they don't understand that this is an x number right here. Find where x is 1. X is 1 is right here, right? X is 1. So f of 1 is this number right there. That's f of 1. That's 1. What's g of 1? G of 1 is 6. All right, so this is not a hard problem. 1 plus 6 is 7. That's your answer, 7. But people don't know where to look. Their eyes go crossed, and there's too many numbers or whatever. So now we want g of negative 1 times f of negative 1. So again, understand that you're given an x number. You've got to find that x number in the table right here. X is negative 1. So notice they flip it around backwards on you there, but g of negative 1 is 2. f of -1 is -3. 2 times -3 is -6. Next, we look at composition of functions. And this one gets kind of difficult, especially when you're talking about the domain, I think. Um, but a composition of functions means you plug one function into another. And notice the symbology. You've got this symbol, this little O symbol. Don't get that confused with multiplication. That's not multiplication. That's this thing. Composition means you plug a function into a function. Okay. I think it's easier to look at like this. This means the exact same thing. F of g of x. That means I've got a function g inside of a function f. That's what that means. So when I look at part A, 6a, I read it as f of g of 1. So you kind of have to do almost like an order of operations problem. You have to do g of 1 first, and then you're going to take that result and plug it into the f function. All right, so g of 1. G of 1, here's g, right? Here's g. So g of 1, just plug in the 1 right there. 5 times 1 plus 4, that's going to give me 5 plus 4, that's going to give me 9. Okay, g of 1 is 9, but I have to do f of that result. So I need to do f of 9. I'm going to plug 9 into the f function. Here's the f function. 2 times 9 plus 6. That's 18 plus 6. That's 24. I kind of like those, but I'm weird, so whatever. Next problem, you're plugging in an x. You're plugging in an x. And so that says f of g of x. People get super confused here because it's an x, and so that means it's hard. But the thing is, we already know what the g function looks like with an x plugged in. The g function with an x plugged in is exactly 5x plus 4. G function with an x plugged in is 5x plus 4. So what's weird, I guess, is we have to plug that into our f function. Plug in 5x plus 4 into the f function. So the f function says 2 times something plus 6. That's what f does. 2 times something plus 6. But we're plugging in 5x plus 4. It's weird. You're plugging a function into another function. At this point, it just becomes simple algebra. We're going to simplify. We're going to distribute and get 10x plus 8. Don't forget this plus 6 over here. Combine your like terms. That's going to be 10x plus 14. 10x plus 14. Questions on that? Number 7 adds a little twist. It says and give the domain, but it's otherwise the same thing. We want to find this composition and give the domain. So they're asking me for f of g of x. G of x is just this. So that's 2x plus 5. I'm plugging 2x plus 5 into the f function. Okay. The f function says square root of 4 times something plus 28. That's the f function. A lot of times that's a number. This time it's not. Plug in 2x plus 5. Distribute. That's 8x plus 20 plus the 28. That's 8x plus 48. Don't forget about the square root. Technically, we could simplify that because both of those are divisible by 4, but I'm not worried about that at this point. Okay, square root of 8x plus 48. That's the value, but now we need to give the domain. Okay, so for domain, a lot of times it's all real numbers, but you have to think about these potential problems. I don't have a fraction. I don't have a variable on the bottom of a fraction, so I don't have to worry about that. But I do have a square root of a variable, so I do have to worry about getting a square root of a negative number. All right, so how we take care of that is we would just say this 8x plus 48 can't be negative. So if it can't be negative, we say greater than or equal 0. So subtract the 48 over 8x is greater than or equal negative 48, and divide by 8. X is greater than or equal negative 6. X is greater than or equal negative 6. Now notice, X is allowed to be a negative number here, okay? X is allowed to be a negative. It's just this thing is not allowed to be negative. All right, but we've got X is greater than or equal negative 6. I think the best way to look at it is look at a number line. If you were going to graph this on a number line, it's going to look something like this: filled in circle on negative 6, arrow to the right towards infinity. So just think about the interval for that chunk right there. That's the domain. The domain is bracket negative 6 to infinity. Last one, another composition. Find f of g of x. F of g of x, and give its domain. So we know g of x. G of x is 2x. So we want f of 2x. We're plugging 2x into the function. That's what a composition is. Function in a function. So f is the function that does this: 5 over something plus 10. F is the function that does that. But we're plugging in a 2x. And so there's nothing really to do. We're just going to get 5 over 2x plus 10. 5 over 2x plus 10. Now for the domain, you got to find your potential problems, okay? Potential problems, I could possibly have a 0 on the bottom. I won't have to worry about a square root, but I do have to worry about a 0 on the bottom of that fraction, okay? I'm not allowed to have 0 on the bottom of the fraction. So when that happens, all you have to do is just say this bottom can't equal 0. That bottom can't equal 0. So subtract the 10 over 2x can't equal negative 10, divide by 2, and x can't equal negative 5. X does not equal negative 5. So again, you know, if you can skip this step, go for it. But I think the easiest way to look at it is look at a number line. If x cannot equal negative 5, then that means that it can equal everything else. You'd have a hole here, but you'd have pretty much everything else colored in. Everything except negative 5. And so in order to write out the domain, you're going to have to look at this in two pieces. There's this piece that goes from negative infinity to negative 5. So your domain is going to be from negative infinity to negative 5. But you're also going to have this piece that goes from negative 5 to positive infinity. So we're going to union that with negative 5 to positive infinity. That gets everything covered except negative 5, and that's what the domain is.